So here we will be talking about vertical asymptote. Okay. So before that, so here we have a function f of x equals to 2x over x plus 1. This is our rational function. Okay. Now, for this rational function, what happens to our function when our x is equals to -1? So if we take our x equals to -1, we have our f of x equals to 2 times -1 divided by -1 plus 1. This is -2 divided by 0, which is -infinity, right? So when our value of x is equals to -1, our function f of x, or which is y, is -infinity. Now what does it mean on our graph? So let's go ahead and graph this function on our graphing calculator. Okay, so here we have f of x. So let me use y for f of x. So we have y equals to 2x divided by x plus 1. X plus 1. So this is the graph for this rational function. Now what do we have, or what do we have when our x is equals to -1? So x equals to -1 means, so this is our x equals to -1, right? So when we have our x equals to -1, f of x is -infinity. It means, so you see, it's like if we go all the way down, the function goes to the -infinity. Okay. Now here, that x equals to -1. So that x equals to -1 is a vertical line. Okay. So here we have x equals to -1, the blue vertical line. Okay. And this graph, it never touches vertical line. It does not matter how far you go below and above. Okay. Like if we go all the below, so it never crosses that vertical line. Okay. And it's the same thing if we go up this portion of graph, it never touches this vertical line. Okay, our function goes to -infinity. So here, okay, so for x equals to some values, if our function f of x is positive infinity or -infinity, then we call x equals to -1 as a vertical asymptote. Okay, so this x equals to -1 is a vertical asymptote. So vertical asymptote, this is a vertical line. Okay, it's a vertical line where the graph does not touch that vertical line. Okay, or is the value of x where our function is undefined. Is the value of x when our function is positive infinity or -infinity. Okay, so when you are asked to write down the vertical asymptote, you are writing an equation for that vertical line. Okay, and to find vertical asymptote for any rational function, we find a number that make denominator equals to 0. Okay, so in this case, our x, when our x is -1, denominator is 0. So x equals to -1 is the vertical asymptote. Now next function. So here we have a function f of x equals to x plus 2 divided by x square minus 1. Now for what x values our denominator is equals to 0? Can you think of a number for x which make our denominator equals to 0? +1 and -1, right? So when our x is equals to +1 and when our x is equals to -1, our denominator is 0. It means this x equals to 1 and x equals to -1 are the two vertical asymptote for this rational function. Okay, you find a number that make denominator equals to 0. And x equals to that number is a vertical asymptote. Okay, so this is the vertical asymptote for function f of x. Now in a graph, let's draw this function. We have, So we have f of x, or let me use y equals to, is it x plus 2, right? Okay. So x plus 2 parenthesis divided by, I'm drawing a graph for that function, okay, x square minus 1. So this is the graph for our function, okay. So this is our, okay, so this is the graph for this rational function, okay. Now we know our vertical asymptote is at positive 1, so this is positive 1, this is negative 1, okay. So let me draw those two vertical lines. So x equals to positive 1, and let me draw x equals to negative 1, okay. So these two vertical lines are the vertical asymptote. Now if we go all the way down and all the way up, the graph, it never touches this vertical asymptote, okay. So it doesn't matter, okay, how far you go, the vertical asymptote, okay, the graph does not touch vertical asymptote. Now from here, what are these 1 and negative 1 for this function? Are these the domain for this function, 1 and negative 1? No, right? So here, when our x is positive 1 and negative 1, this function is not defined. It means 1 and negative 1 are not the domain for this function. Okay, so vertical asymptote is the vertical line that we draw at a number which is not a domain for that function. Okay, so if you have a graph and you are asked to write down the domain for this function, then the vertical asymptote, we have vertical asymptote at negative 1 and positive 1. So these two numbers are not the domain, but all number on the left of negative 1, in between a negative 1 and positive 1, every number on the right of 1 are the domain. Okay, that's how we can find the domain of a function. So if you have a vertical asymptote for any graph, those vertical asymptote are not the domain for a function, okay. Now next here we have a function f of x equals to x squared minus 3 divided by 2x plus 1. To find the vertical asymptote, okay, to find the vertical asymptote for this function, we find a number that make a denominator equals to 0. So our denominator is 2x plus 1. Now can you tell me a number which for x which make this expression equals to 0? Negative half, right? So if you feel difficult, what you can do, you take the denominator, okay, you take the denominator and make it equals to 0. You solve this equation and you can find the value of x that make a denominator equals to 0. Okay, so here we have 2x equals to negative 1. You divide by 2 and our x is negative half, and this x equals to negative half is a vertical asymptote for this rational function. Okay, if you could not find a number by observation, write down to that denominator and make it equals to 0. You solve that equation and the solution for that equation is the vertical asymptote. So this is the vertical asymptote for this function. Okay, so there is a vertical line at negative 1/2. Okay, any question about finding a vertical asymptote? You find a number that make a denominator equals to 0 and x equals to that number is a vertical asymptote. Okay, and when we have a vertical asymptote, our function is not defined. Okay, and we use a vertical line to represent that point on the x-axis. Okay, so vertical asymptote is the point where our function is not defined. Okay, next here we have the horizontal asymptote. Okay, it's the horizontal line. Now, so okay, so let me take this function and you graph this function. Okay, so it's the same function here. Okay, it's the same function. and let me draw y equals to 0 here. So y equals to 0, we have a horizontal line. Okay, so here now when our value of y is 0, so value of y 0 means when we have this horizontal line, what happens to our function on the right side? So when we have our y equals to 0, our f of x is positive infinity. Like if you go all the way to the right, this, the green is the for the function, okay, the red is the our horizontal line y equals to 0. Okay, it doesn't matter how far you go, the function never tosses our horizontal line. Our function goes to positive infinity. Okay, in the similar way on the left side, so on the left side here, okay, so our green is the graph for a function, red is the our y equals to 0. Okay, when for the value y equals to 0, our f of x, okay, our x is negative infinity. Okay, our x goes to negative infinity. These two never crosses. Okay, they are very close to each other, but they are never they never crosses each other. So here, so finding a horizontal asymptote means we are finding a horizontal line. Okay, horizontal line. So in general, so if our function f of x, okay, let's say goes to, okay, instead of, so let me rephrase this here. So for, like, let's say for x equals to, so when our x goes to positive infinity, it means when we are going all the way to the right. Okay, if our y goes to some number, okay, if our y is close to some number, so let me, so if our y is close to some number, let me call a, then y equals to a is a horizontal asymptote. Okay, in the similar way, as our x approaches to negative infinity, it means when our x is very small number, okay, if the value of y, it means if the function approaches to some number, let me call b, then y equals to b is a horizontal asymptote. Okay, so when our input, x is the input, okay, x is the input, y is the output. So when your input is very big or when your input is very small, and if the value of y or if our output is close to some number, then y equals to a is a horizontal asymptote. Okay, so in this case, so when we go on the left side, so going on the left side means when we choose our x to be very small number, then our value of y is close to 0. Okay, so this, so if we go here on the left, the value of y, so let's see the y for this point. So y for this point is negative 0.03, right? So if we go all the way to the left, the y, it is very close to that number 0. So the coordinate is all, okay, not here. So let's find the coordinate of this point, which is negative 0.01. Okay, it means when our x is very small, when our x is very large, the y or the output is very close to some number. Okay, and that y equals to that number is our horizontal asymptote. Okay, and there is a way to find horizontal asymptote. Okay, and it depends on the degree of numerator and degree of denominator. So here they use m. So let's say our n is the degree of numerator, okay, p of x, and our m is the degree of denominator, q of x. If our degree of numerator is less than degree of denominator, then y equals to 0 is always a horizontal asymptote. Okay, so first example. Now what is the degree of numerator? So this is our numerator. What is the degree of this numerator? So degree means is the highest power of a variable. Okay, so here we have a variable x, and this x has a power 1, and that 1 is the highest. So 1 is the degree of numerator. And what is the degree of denominator? 2, right? So 2 is the degree. So here the degree of numerator is less than degree of denominator. And if you have a rational function where degree of numerator is less than degree of denominator, then your horizontal asymptote is always y equals to 0. Okay, it does not matter what function you have. If the degree of numerator is less than degree of denominator, y equals to 0 is the horizontal asymptote. Okay, it means when you choose x to be a very large number or a very small number, our output for a function is very close to 0. Okay, next, if the degree of numerator and degree of denominator is equals to 0, okay, so our n is the degree of numerator, m is the degree of denominator, and if these two are equals to 0, then our horizontal asymptote is y is the coefficient of the leading term divided by coefficient of leading term in the denominator. Okay, so here what I mean here, so we have a second function. What is the degree of numerator here? What is the degree for 2x? No, 2 is the coefficient. So degree means exponent. Okay, 1 is the degree of numerator. And what is the degree of denominator? This is the denominator. What is this degree? 1. So here we have the degree of numerator and degree of denominator equals to each other. And if this is the case, if you have degree of numerator and degree of denominator equals to equals to each other, then your horizontal asymptote is y equals to coefficient of leading term. So we have only one term, its coefficient is 2 divided by coefficient of leading term from the denominator, and its coefficient is 1. So y equals to 2 is the horizontal asymptote. So if our degree of numerator and degree of denominator equals to 0, then y equals to coefficient of leading term of a numerator. So this is the coefficient of leading term from the numerator, and this is the coefficient of leading term from the denominator. Okay, so and this will be the horizontal asymptote for this function. Now what does it mean? So what is y equals to mean for us? It means when your input x is very big or very small, our output is very close to 2. Okay, that's what we can see on our graph. So if we graph here 2x, so let me graph this function. So we have y equals to 2x divided x plus 1. So this is the, okay, so where is our graph here? Okay, so this is the graph. Now when you take your x to be very large, okay, so if it means if you go all the way to the right, the value of y is very close to 2. Okay, so if for this point the value of y is 1.9, right? So let's go right. The value of y is very close, it's never 2. Okay, it's never equals to 2, but it's close to 2. The value of y is 1.97. okay, it doesn't matter how far you go. So let's find the value of y, 1.979. okay, and it's the same thing on the left side. It is never equals to 2, but it is very close to 2. Okay, and here we can draw that horizontal asymptote, and that is y equals to 2. So this y equals to 2 is our horizontal asymptote for this function. Okay, now let's go to the next here. Now if the third case is, if our degree of numerator is greater than degree of denominator, then there is no horizontal asymptote. Okay, so for the horizontal asymptote we have a 3 case. Okay, you need to know what is the degree of numerator, you need to know what is the degree of denominator. Okay, if degree of numerator is less than degree of denominator, y equals to 0 is always horizontal asymptote. If degree of numerator and degree of denominator equals to each other, then y equals to coefficient of leading term of a numerator divided by coefficient of leading term of a denominator is the horizontal asymptote. The last case, if degree of numerator is greater than denominator, degree of denominator, there is no horizontal asymptote. Again, part C, what is the degree of numerator? So what is its degree? 2. What is the degree of denominator? 1. So here we have degree of numerator greater than degree of denominator, and because of this there is no horizontal asymptote. Okay, any question in finding the horizontal asymptote and a vertical asymptote? Okay, now let's see what we have next here. Now next here we have to know how to sketch the graph of a rational function. Okay, you can always use your graphing calculator to sketch a graph. Okay, but if you are asked to show all this detail, then whenever you have a rational function, we always need to find the vertical asymptote. Okay, so let's go ahead and find the vertical asymptote for this function. So let's start with vertical asymptote. So how do we find the vertical asymptote for this function? To find the vertical asymptote, we find a number that make denominator equals to 0. Now what are the number for x that make our denominator equals to 0? X equals to 1 and x equals to -1, right? So x equals to 1 is one vertical asymptote, and x equals to -1 is the second vertical asymptote. Now the next, we find the horizontal asymptote for the function. We also need the horizontal asymptote. To find the horizontal asymptote, we need to know the degree of numerator and a degree of denominator. What is the degree of numerator? It's 1, right? What is the degree of denominator? It's 2. So what do we have? We have degree of numerator less than degree of denominator. And if this is the case, horizontal asymptote is always y equals to 0. So it's not only 0. If you write 0, it's not a answer. Okay, make sure you have to have a y equals to. These are a horizontal asymptote is a horizontal line. Vertical asymptote is a vertical line. Okay, so if you write down 0, then that is incorrect. 0 is a number, but you need a horizontal line, and this is how we write down horizontal line, and this is how we write down vertical line. Okay, the next we find the x and y intercept. So let's find x intercept for this function. So how do we find x intercept? Our function f of x is x plus 2 divided by x square minus 1. How do we find the x-intercept? So x-intercept are the point on the x-axis, and every point on the x-axis has y coordinate 0, right? So you replace y by 0. And where is y here? Which is y? F of x is y. Okay, so this is our y. So let's replace this by 0. We solve this equation and we get our x-intercept. Now to get rid of x square minus 1, from denominator we multiply both sides by x square minus 1. So this x square minus 1 and this x square minus 1 cancel. We have 0 on the left side, x plus 2, you subtract 2 on both sides, x equals to -2 is the x-intercept. Okay, so our graph crosses x-axis at -2, 0. So when we draw a graph, our graph must cross at -2, 0. Now let's find the y-intercept. And how do we find y-intercept? So it's the same function. So it's the point on the y-axis, right? Every point on the y-axis has a x coordinate 0. So you replace every x by 0. to find the y coordinate. So we have 2 divided by 0 minus 1 minus 1, negative 2. So 0, negative 2 is the point where the graph crosses y-axis. Find the vertical asymptote, find the horizontal asymptote, and you find the x-intercept, y-intercept. Now next, now it tells us to find some more point. Now at first let's draw this information on our coordinate system. Okay, so let's have a x-axis, y-axis, origin. So this is 1 2 3 4 5, 1 2 3 4 5, so on, negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, make sure to have a scale, okay, when you draw a graph. So let's plot our x-intercept. Okay, or let's start with our vertical asymptote. How do we draw vertical asymptote? It's a vertical line. Okay, so you draw vertical line at 1 and negative 1. So let's draw vertical line at 1 and negative 1. So this is our x equals to, this is our x equals to 1. How do we draw x equals to negative 1? That is also a vertical line at negative 1. So you draw a vertical line at negative 1. So this is x equals to negative 1. So these two are our vertical asymptote. Now let's draw horizontal asymptote. Horizontal asymptote is y equals to 0. Now how do we draw y equals to 0? It's the same as x-axis, right? So we have this line as our horizontal asymptote. Y equals to 0. So you draw vertical asymptote, you draw horizontal asymptote. Now let's draw x-intercept. Let's plot x-intercept. So negative 2, 0 is x-intercept. So this is our x-intercept. Oh, this is not x-intercept. That's x-intercept has to be on the x-axis, right? So this is this is not what I want. Okay, so this is our y. So this is our x-intercept, negative 2, 0. Okay, now what about y-intercept? Oh, y-intercept is also 0, negative 2, right? So this is not incorrect. So this is our y-intercept. Okay, any question up to here? Drawing vertical asymptote, horizontal asymptote, x-intercept, y-intercept. Okay, now let's find some more points. Okay, we need to draw a graph. So let's take some points here. Okay, some point very close to a vertical asymptote. So when our x is, let's make a table. Our function is same. Okay, our function is x, is it x plus 1? Okay, x plus 2 divided by x square minus 1. So x, we find f of x, x and f of x give us a point. Okay, now let's take a point, at least one point close to vertical asymptote. So let's start with x equals to 1. So let's take 1.5. So when our x is 1.5, or let's take 2, okay, make it easier. So when our x is 2, what is our y? What is our output? So when our x is 2, what is our output? How do we find? We substitute 2 for every x in the function. So we have 2 plus 2 in the numerator, 4 divided by 2 square minus 1, that is 4 minus 1, 3. So we have 4 divided by 3, and 4 divided by 3 is 1.3. Okay, so we have 2, let's see, 1.3 as a 1 point. Now let's take some point on the right. So let's take like a 5. So when our x is 5, 5 plus 2, 7, divided by 5 square minus 1. So 7 divided by 25 minus 1, 24. 7 divided by 24. Okay, now I need your help here. 0.29. Okay, let's take 3. Thank you. 0.3. So we have 5. 0.3 is the second point. Now let's take some point on the left of x equals to 1. So let's take 0.5. So when our x is 0.5, 0.5 plus 2.5 divided by 0.5 square minus 1. That's 0.5 square. Is it 0.25 minus 1? That's negative 0.75. So 2.5 divided by minus 0.75. It's going to be negative number. So you just replace x by 0.5. So we have 2.5 in the numerator. And 0.5 is negative 3.3. Okay, thank you. Negative 3.3. So the next point, 0.5, negative 3.3. Now let me take some number from here, negative 0.5. So if I take negative 0.5, so we have negative 0.5 plus 2. That is 1.5 divided by negative 0.5 square minus 1. I need your help here. So you replace every x by negative 0.5. Make sure to have parentheses for x squared, okay? Negative 2? Okay, thank you. So negative 2. So the next point, negative 0.5, negative 2. Now let's take 2 more. So let's take one here close to vertical asymptote, which is negative 1.5. Okay, so if negative 1.5, so if our input is negative 1.5, then our output is, so negative 1.5 plus 2, that is 0.5. Negative 1.5 square, that is 2.25 minus 1, 1.25. So 0.5 divided by 1.25. Is it, do we get negative or positive? I think we get positive. Not sure. How much? 2.5? Thank you. Okay, so negative 1.5, 2.5. Now let's take one last point. So let me take somewhere here like negative 6. So if our x is negative 6, then that's negative 4 divided by 36 minus 1. Negative 4 divided by 35. That's negative. Is it negative or positive? Negative again, negative 0.1. Okay, 0.1. Thank you. Okay, now let's plot all these points, then we get the graph. Okay, so at first 2, 1.3. So 2, 1.3. So this is our 2, 1.3 somewhere here. Okay, so this is 2, 1.3. 5, 0.3. 3, 4, 5, 0.3, close to here. Okay, 0.5, negative 3.3. So 0.5 here. This is 0.5, negative 3.3. This is 3 somewhere here. Negative 1.5. So negative 0.5, negative 2. Okay, here. Do we get a negative 2 here? Let me double check. So when our x is negative 0.5, do we really get negative 2? So negative 0.5 plus 2, positive 1.5 divided by, can you double check this one, please? When our x is negative 0.5, do we get negative 2? Let's see. So we have negative 0.5 plus 2, that is positive 1.5, divided by negative 0.5 square, that is positive 0.5, no, positive 2.5.
I got negative 1.2.
Negative 1.2. Okay, does anyone have different than that? Negative 1.2. Okay.
Just 1.2.
A one positive 1.2.
Negative. I got
Oh, yeah,
negative.
Negative 1.2. Okay, so let me correct this one. Okay, this is negative 1.2, and that is
Yeah, I think the next one is
negative 1. So 1.2 will be somewhere here. It does not look good here. Okay, so we have okay, so negative, so this is negative 0.5 plus 2 divided by minus 1. Negative 0.5 square is 0.25, right? Minus 1.5 divided by negative 0.75. So we get negative, and 1.5 divided by 0.75 is 1. So 1.5 divided by negative 0.75 is 1.2. Okay, that's a 1. 75 times 2. Okay, looks, it should be good. Okay, now,
next one, it was minus 0.15.
oh,
For
for this one
down.
here. So how much you said?
Negative 0.15.
0.15. So let's take like a 2. Okay, and we can always use our graphing calculator to double check, okay, the graph. Okay, let's plot these points. So we have negative 0.5, negative 1.2 somewhere here. Then we have negative 1.5, negative 0.2. So 1.5 is here, and negative 0.2 somewhere here, and negative 6, negative 0.1. 2, 3, 4, 5, 6, negative 0.1. Let's use our graphing calculator. Okay, so let's see how our graph looks like. Then I will use that and draw here. So our function is, and you do have a calculator, so you can always use it. So if you have a close enough, then you get the credit. Okay, so we have x equals to, is it x plus 2, x plus 2, sorry, x plus 2 parentheses divided x square minus 1. Okay, now our graph must look like this one. Okay, so let's draw our vertical asymptote here. X equals to negative 1, x equals to positive 1, and let's draw horizontal asymptote y equals to 0. So our graph should look like this. Okay, so I think we were correct. When our x is 1.5, so when is negative 0.5, we get negative 2. I think who gave me negative 2? It was correct. So yeah, this was correct. Okay, my bad, I'm sorry. So here, yeah, where we end up getting negative 1.2. So this is negative 2. Now let's use the now here our graph looks like. Make sure not to cross this horizontal vertical asymptote. Okay, when you draw a graph, do not cross or toss this vertical asymptote. So graph, so very close to vertical asymptote. Okay, now you and next here, okay, let double check. Okay, it crosses x-axis at 2 and it close to x-axis. And I will just make sure I will give you a easier function, okay, easier than this function to graph a rational function. But when you graph this rational function, make sure to find the horizontal asymptote, vertical asymptote, then the x-intercept, y-intercept, and make a table. And when you make a table, you take the x very close to x vertical asymptote and very far to the x-intercept. Okay, it will help you to get the very close graph. Okay, now let's skip this one. Let's not do this one. Now here, so for this function, the degree of numerator is 2, right? The degree of denominator is 1. So the degree of numerator is greater than degree of denominator. Do we have a horizontal asymptote for this function? No, it does not have a horizontal asymptote. Okay, no horizontal asymptote. But here it's asking us to find the slant asymptote. Okay, it's a inclined straight line. Okay, but that is not required here. So let's do this much for this section.